One of the more interesting features of case classes is that the objects they create are immutable. This is very significant for a number of reasons, and it's worth looking at how this can work and how you utilize this in your programs. So if we open up the Scala RAPL and we define a case class, we'll make some arbitrary type here. We'll call it a player. And the player has a name, which is a string, and we'll say player has a location defined by an X and a Y. Now, one of the things that might happen when a player is playing a game is that they move around. So this winds up being significant for the immutable part, in that if you'd create a val for a player and we give them a location, well, I can get out the values of p.x and p.y. I cannot assign to them. So that is, you're not allowed to make that change because the name, the x, and the y values are all vals, basically. That's part of being a case class. On the other hand, so while this is helpful and you can utilize it, you don't have to worry about pieces of code messing with your instances, there are times when you want to be able to change things. For example, if the player were supposed to move around in this, so we had a def move right that takes a player, well, it cannot modify that player, so it is going to give us back a new player. And then the question is, what goes here? How do we make a new player that is to the right, so it would have a larger x value? And the obviously we could make a completely new player. We could say something like player of p.name, comma, p.x+1, comma, p.y. That would work. Okay, we could then say move right of the p that we defined above, and we'd get a new player. However, this would become unwieldy, especially if we started adding more and more fields to our player. This isn't so bad when there's only 3 things inside of there, but imagine if there were 7 or 10 or more. That could become problematic, especially in a situation like this where we really only wanted to change one thing. And because that is such a common need, there is a method that comes with being a case class that is called copy. And the way that copy works is it makes a new instance of the case class that uses all of the same values except for the ones that you specify. Now, in order to make this work, we have to use named parameters. So one of the things that you can do with Scala, and we generally have not utilized this, is you can, if there are arguments that have default values, you can leave those off, and then you can specify what arguments match up with what, not by where they are in the argument list, but by specifying the name. So in this case, we can get the same effect that we had before using the copy method. And so what this says is that when you call move right on the player P, it's going to make a copy of P, and it's going to set the x value in this copy to be p.x plus 1. And so you can see we get the same value here. So we didn't have to specifically specify the name and the y value. All that we had to specify was the value of our new x. And once again, this would be particularly helpful if the number of parameters were particularly large. And so using this, we could also make a def move left which takes a player and gives back a player, and it's p dot copy with x equal to p dot x minus 1. Now, of course, to make these usable, instead of declaring a val p, we really would have wanted to have p be a var, so that we can do things like this. And then we can say p equals move right of p. By making it a var, then we can assign new values into there, and repeating this multiple times allows you to see how you get somewhat different, or we get modified values where the x has been moved over. So that's something to keep in mind when you use case classes. There are ways of making mutable classes in Scala, but for now we're primarily using our classes to group together data, and so we will typically prefer the immutable case class. That's it for this video. Hopefully we'll see you again soon.